Hello MAA students, we are going to look at another example on mathematical induction. So we have to prove by mathematical induction that this is true, right? That's my things on the left hand side, that's on the right hand side. So step 1. Step 1 says that show that n is equals to 1. In place of n, I am going to substitute 1 and get the answer. Left hand side answer is equals to the right hand side answer. You can see left hand side is equals to right hand side. Now step 2. In step 2, I have to assume that n is equals to k. That means everywhere that I have a n, I will substitute it with k. There you go. There you go. And can you see I've written 3 there? That means I am going to be using this. I am going to be using this expression in step 3. Okay. Now let's look at step 3. Step 3 says prove that n is equals to k plus 1. That means everywhere that I have written a n, that was we had a n, I'll replace it with k plus 1. Right? So this is exactly the same from step 3 there. And then plus, instead of k, I'll use a k plus 1. So plus k plus 1. So the one in black is from your step 3. And this is what I have done. K plus 1. And on this side too, k plus 1 squared, k plus 1 squared divided by 4. Right? Now, we have substituted it. Now, we are going to be simplifying. So, this portion here, that you can see, this portion, that can be replaced with this because this is equal to that. Yeah? So, and this is equals to that. So that I can substitute that here. Okay, you will see that in the next step. Alright, so I've substituted that there. You can see plus k plus 1 squared and k plus 1 squared, k plus 2 squared when simplified is 4. Now we're going to be simplifying our left hand side and our right hand side. Let's quickly work on the right hand side. So basically I'm expanding the brackets. K plus 1 squared will be that, k plus 2 squared will be that. Divide by 4. When I expand that bracket, it's going to look something like that. Yeah? Multiplying the terms of first bracket to every term of the second bracket. There, when simplified, collected the like terms, I've collected the like terms, it will end up like this. Right? Same, we are going to do it on the left hand side. We are going to be expanding the brackets and then collecting all the like terms. So you can see that expansion from k plus 1 everything squared comes like that. And then I'm expanding, it's coming like that. K plus 1 cubed. So I've left, that's the first term. This is the next two terms, the k plus 1 squared expanded. And I'm expanding it. So that's there. Then I cannot add the two fractions because my denominators are not the same. And then I can use my primary school fraction knowledge where I have to make my denominator same. So I'll multiply the denominator here by 4 and multiply the numerator by 4. There you go. Right? So once I'm multiplying, I'll expand the bracket to multiply the terms. Yeah, I've expanded the bracket to multiply the terms. Now both my denominators are 4. So when I was in primary school, I know when the denominators are same, we'll just add the numerators. So we are doing that here. Right? Once we are adding, now what we can do is collect all the like terms. So once we collect the like terms, it will end up as this, which is same as the one on the right hand side. So you can see my left hand side answer is equal to my right hand side answer. Right? My conclusion, it is proved by mathematical induction that it is true for all positive integers n. Make sure for the word each, you can always write the expression that's there in the question, that particular sequence is true for all positive integers n. Thank you.